Hello ladies and gentlemen, this is Mr. Green and I'm making another recording in my series of Algebra 2 recordings. I want to point out to you guys that we are now finished with Unit 5, so you should have or be in the process of taking the Unit 5 test, Part 1s and Part 2s, getting those turned into me because they are due. 28 days from now they will turn into past due and they will get locked, so you want to make certain you get them done and get them turned in. Otherwise, they do lock up and you get a 0. You don't want to have that happening. Okay? So what we're taking up now is the concept of dividing monomials and polynomials. So we're going to determine the domain restrictions that we might have with rational expressions and do some simplification of rational expressions. What are we talking about? Well, when we're talking about dividing monomials and polynomials, what are we actually talking about? We're talking about a ratio. A ratio is a comparison of two quantities. It's written as a fraction. Oh, Mr. Green, fraction, the F word in mathematics. Yes, I know, but we're going to talk about fractions. We're going to try to go through this over the next couple of lessons and make certain you know how to deal with all the fractional situations that we're going to be dealing with, okay? So, a rational expression is a ratio whose numerator and denominator are polynomials, and the denominator is not 0. So that's what we're talking about. That's what we're going to be looking for domain situations, is when that denominator is a 0, because we do not want to include those in our domain. So looking at this, first thing you're going to want to do, you're going to want to make certain that there is nothing that can be factored in the numerator and the denominator. So looking at this, I see an x that could come out of this, and it would become x times 3x squared minus 7, which is of no help at all to the 4 minus 3x on the bottom. Okay? So I want to check. 4 minus 3x, can that ever equal 0? Yes, it can. I can subtract 3x from both sides, and I get 4 is equal to 3x. Divide by 3, and x is equal to 4 over 3. When x is equal to 4 over 3, you've got a 0. That is an undefined division. So what you say is the domain is x's such that x includes everything except x not equal to 4 over 3. And that would be your domain for this value. Now looking at this one over here, like I said, you want to look for things that can be factored out. So I could factor this numerator up here. Could I not? Let's see here. 5 times, what times what is 5? That adds up to 10. 5 times 1 is 5. That only adds up to 6. So the numerator cannot be factored at all. So the denominator, could it be factored down into some things that we could set equal to 0? And 48 is a combination of 6 times 8. So that's going to be 6 and an 8. And since it's a positive number, the 8 is going to be a positive, and the 6 is going to be a negative. It's going to be x times 8 and x times negative 6. Or x minus 6 and x plus 8. And so what we'll do is we'll say x minus 6 equals 0, or x equals 6, and x equals negative 8. Those would be my two values that I would want to exclude from the domain. Why? Because if x equals 6, I get 36 plus 12, which is 48, minus 48 is 0. If x equals negative 8, I get 64 minus 16, which is 36, which is 48. 48 minus 48 is 0. I do not want a 0 in the denominator. So I would say that my domain would include all x's such that x is not equal to 6 or negative 8. And that would be my domain. Okay? Domain's really easy. You just got to think about those x values. Looking at this equation that we've got up on the board now, this first one over here. Okay? I've got 8x squared and y to the 5th, 24 divided by 24x y to the 7th. Well, I can do some simplification. 8 goes into 24 3 times, so that'd be 1 over 3. X squared gets divided by x, and it comes out with an x on top. Okay? And y to the fifth and y to the seventh, that comes out with y squared on bottom. So, are there any x values that would make the denominator 0? And there are none. So this would be all real numbers. How about this one over here? Well, I can see that there'd be a 4 in the numerator up here, and that would leave me with a 2a squared minus 10a plus 8. Okay? And 8 times 1 is 9. I'm sorry, 16 is what I'm looking for here. And 8 times 2 is 16. So I could have 2a and 2a, let's see here, minus 2a squared minus 2a. I always have to do this. Plus 8a plus 8. Well, that's going to be a minus 8a plus 8. Okay, that's going to factor out into 2a times a minus 1 and minus 1 times a minus 8a minus 1. Okay, so what do I get as my factors? I get 2a minus 1, sorry, 2a minus 8, and a minus 1. Well, does that help me at all with a 4a down here? No, but my 4's cancel out, and it's going to leave me with this as my factors. 2a minus 8 and a minus 1 on the numerator and a in the denominator. So are there any values I need to leave out? Yeah, a equals 0. So my domain is going to be x such that x not equal to 0. That's what my domain would be. Okay, let's look at a few more. Looking at this one, well, they've already factored it for me, so that's real nice of them. And I notice this x plus 1 and this x plus 1 cancel each other out. And that just leaves me with an x plus 3 and an x plus 2. So I would look for x equal to negative 2 not be in my domain. So my domain would be x such that x not equal to negative 2. Okay? Over here, factoring, I start in the numerator up here. So that's going to be 3x squared plus, let's see here, 12. 12 and 1. Nope, those are at 16. I'm sorry. It's 36 that I'm looking for. Well, 36 is actually 6 and 6. Nope, that's not going to help me. 8 and 3. Let's see here, 6. No. Sorry, should have that factored before I come in here. I don't have it factored. Hang on a second. Let's see here. Multiplies out to 36, adds to 16. Well, that's 18 and 2. Yep, 18 and 2 will do it. And it's got to be a negative 18 and a positive 2. Okay. (3x minus 18x plus 2x minus 12). I group the first two together, and I group the last two together. And what do I get here? I'm going to pull out a 3x out of this one, and it's going to leave me with an x minus 6. And I'm going to pull a minus 2 out of this one. No, I'm not. I'll leave it as a positive 2. Okay. I'm going to pull a positive 2 out of this one, and it's going to leave me with an x minus 6. Well, x minus 6 is common to both these, so what are my two factors for my numerator? It's going to be 3x plus 1 plus 2, 3x plus 2, and x minus 6. Okay, factoring the denominator down here, I've got has to multiply to give me negative 24 and add to be 2. Well, let's see here. That's be 4 times 6. So I'm thinking this is going to be x minus 6 times x plus 4. Let's see here. That's going to give me a negative 24 and a negative 2. Whoops. It's going to have to be x plus 6 and x minus 4. Yep. Okay. Well, I didn't wind up with a factorable thing there. Why not? Let's see here. If I pull out a 3x, that becomes an x minus 6. Yep. If I pull out a 2, that becomes an x minus 6. Yep. So those aren't factors of each other, are they? This is x minus 6 up here, and this is x plus 6 down here. So since they're not factors, I can't really cancel anything. So what am I looking for as my domain? X equals negative 6, and x equals positive 4. So my domain would be all values of x such that x not equal to negative 6 or positive 4. Okay? Little brackets there didn't do very good. Okay. One last one here because there's a trick you need to be able to see how to do. I'm going to factor a 5 out of this numerator out here, and it's going to be 5. It's going to be x squared. I'm going to actually factor 5x out of it. X minus 4. And in the denominator, I've got 4 minus x. And you're looking at those and you go, well, those aren't factors of each other. One of them is positive and one of them is negative. But there's a trick that can be played. If I stick a 7 in for x in this situation, 7 minus 4 is a 3, and 4 minus x is a negative 3. And we know we can cancel those and get negative 1. And that's what happens when you're looking at something like this. We've got x minus 4 and 4 minus x. That's actually saying those do cancel and give you a negative 1. And so what we would get in this situation is a negative 5x as my value. And that's in the numerator, and this is over 1. So my domain is going to be all real numbers, but you just need to be able to see that there is a factor that is sitting there. Okay? Now, as I say every time, I do appreciate you guys sending me the fact that you're in Algebra 2 because that does help me find your records quickly and be able to answer questions for you, knowing what you've studied and where you're at, and helps me answer those questions a whole lot easier than if you don't tell me. So I appreciate it. You guys are doing a good job. Keep it up, and I will see you next time I see you.